Alrighty, welcome back everybody. How are you doing? Today we are gonna hopefully achieve something pretty good. Also, I will need to increase volume on my music a little. That's too loud. That seems like it's too loud still. I don't know, I can't hear myself, that's the issue. Yeah, should be fine. The only thing that matters is that you can hear it on stream. I seem to be able to. Yeah, should be fine. The only thing that matters is that you can hear it on stream. Yeah, I can hear something. Alright. So, in case somebody, for whatever reason, decides to visit the stream, I'm gonna pop out chat. Not that I'm gonna read it. I mean, I'll try, but as I said. Alright, enough of wasting my time. Let's start doing something. First of all, I wanted to show you that, oh, the resolution is fucked up. You might not be able to see everything, I don't know. Well, we have, oh my god, it's so terrible. Is it the same on stream? Hang on, just need to know. Probably is. One sec. I need to know how terrible it is. It's so just, bro. Actually, it's pretty smooth. Okay, it's OBS fault. It's OBS's fault. Anyway, we can have movement now finally, and I had, finally figured it out. Um, we have some movement here, and I now am finally able to move all the, like each way, like forward, back, and all that. It's doesn't seem to be eating too much of my CPU, and also you can move diagonally, and you don't move with like extra speed. And also I added it so that I can actually sprint a little bit, so you can see how I'm actually like sprinting here. So yeah, that's gonna be useful for doing things. Okay, so I would say that's a success. We have movement, we have collision. We can try and like maybe hit this box a little. Yeah, and like we can try and hit this one. Yeah, so we can play a bit of pool. Can see like collisions happening. It is a little fucked though. It doesn't quite work the way I want it to. But what's nice is that I can actually like stop these cubes. Yeah, that's pretty good. Can do stuff. Stop. Yeah. So we can try arranging them around. Did any of the cubes 4, 6, 8, 10? Okay, all seem to be inside here. I'm just trying to like. Oh no! Stop! 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 All of you! Stop! You! I want them all to stay together. Yeah, I know this is not what we're supposed to do, but like, stop! How did he go through me? Oh, yeah, I know it's not very exciting. This is not the game we're making, by the way. Like, we're not making some kind of box pushing game, although we could, but we're not. Anyway, this is kinda working. Kinda is the keyword. They're moving around. We're able to push them around. We don't have walls just yet, but you know. Hey, you, where are you going? Come back. Come back. Having sprint really does help. And also, if the box is like having enough speed. Oh, I know what the issue is. Like the entire thing is offset a little. Cause like, look, it's not exactly, it's not exactly precise. See how the actual hitbox is a little bit offset? I don't know which way it is offset though. I don't know, they don't touch for some reason. But anyway, if this hits us, we can move a little bit. If it has, of course, enough friction. Oh yeah, look. What is it doing? That's a collision. What are you doing? Stop. Like, I'm not sure why. Yeah, box 2D is weird. Stop! Oh, they're all moving. Anyway, most of the boxes probably flew away. It's three, yeah, they flew away. Oh wait, they're just down here. Yeah. So I wish that they would have a bit more friction to them. I think we can actually fix it. Let me, there is no such thing as like find globally. That'll be pretty cool, but actually inside of this document we can just search for friction. I want friction to be, I don't know, 5. I don't know what this is. Like, how does it work? It's also set. So let's actually set the friction of this one to be 5, but the friction of this one, yeah, let's also set it to about 5. Should be pretty good. Yep. Ah, what's it saying? Error. PR was not declared in the scope. When I was running it, I typed the command. Let's get rid of that. And compile. Um, so what's the goal for today? What are we going to try to achieve? Well, first I think we should make it so that when we add a new system to the game does not recompile in its entirety. Because that seems like a dumb idea. Because currently all of our systems are located in the same. Are they moving? They're not. Also, what's really weird is, actually, you can't. No, I think you can see it a little bit. I'm not sure. What if I do like, uh, yeah, you actually can see. So like, if you look to the boxes, some of them you'll see how there's like specifically here is like a thick um, line, and some of them like this part of the bottom edge does not align with the other part of the bottom edge. I have no idea why that is. It's not supposed to be this way. I have no idea why, honestly. Like this, it's just so annoying as well, because you're like, I want the perfect box, and it gives you this kind of weird thing at the bottom, and you're like, well, what is that? And OBS is, sorry, not OBS, and SDL is like, well, it's just something, and you're like, what? Okay. I don't know why that happens. I have no idea. Just to kind of show what I'm talking about, I'm not sure if that's coming through, but like, um, can I like quickly open up this picture here? Yeah, let me. Oh, wait, it was easier to just do this? I think it's. Yeah, I don't know what this is. Uh, anyway, point is, like, yeah, I can't really. Oh, wait, we can actually try to increase our scale. Let's try increase our scale real quick here. Position to pixels. Oh no, this is not gonna go very well. Let's increase it to about 64. It doesn't seem to be affected. Yeah, look, so I changed this header file. See, the render recompiles. The render should recompile, although not really. Physics recompiles. Why does physics have to do that? Handle events has nothing to do with rendering. And main.cpp, of course. Well, main.cpp, okay, that's fine. But like the fact that it recompiled so much stuff, like that's too much, you know? So anyway, if we run this, you can see it's a little bigger. It's still it still is a really small one. I think I should do something about the actual width of. I should do something about the width of this line, but like it doesn't line up. Although I will admit that that looks a little bit better. You know, it looks a little bit more like Agario. And yeah, can move around. All right, so it does stop almost like instantly, and I don't know. Yeah, we might want to speed up our character a little because one block a second isn't quite gonna work. For now it will because we have acceleration. Anyway, so let me first of all tell you a bit about how I solved the problem with movement because movement did not behave the way I wanted. I wish I took some clips of it, but actually then I would have to display what keys I'm pressing. Um, so so the way I did it is I decided that handle events is only gonna check for SDL quit event. That's the only thing it's gonna check. Everything else is not its responsibility. It does not care about other events. Other events are just not really like we don't care about them. So we're just gonna empty the event queue until we find the quit event. Um, I wish there was some kind of way of signaling it a little bit differently because Paul event seemed really unreliable for me for some reason. I don't really want to dig into why that is. I decided to do it a little bit differently. So this is a float speed. Let's actually increase that a little bit. Let's increase it to about, I don't know, one and a half. So this is where I get the keyboard state. So this keyboard state, get keyboard state. This will return all of the keyboard keys as booleans. Now it puts it into this, basically returns a pointer to some memory that stores all of our keys, or at least information to all of our keys. So what we can do is we can just look into that memory and ask it for uh, the D key, the A key, S key, and W key. And what we do is we know that these are booleans, and SDL sets them to either true or false. And true in case of SDL means 1, and false means 0. So we can just say that um, if let's look at the y first, because y will be the y-axis is going to be a little bit more intuitive for you. So basically, if we're pressing W, we're moving up, so we're adding to our y coordinate. If we're moving down, we are subtracting. So this, you can think of it is if only W is pressed, this will be 1, this will be 0. So that the result will be 1. If both are pressed, the result will be 0, so we're not moving anywhere. And if we press S, then we're going to be moving downwards because the result here will be -1. So what do we do next? Well, next I try to make it like super fucking efficient. Well, not really that efficient as I would want it to be. So the way that it ended up working is we also check here if the scan code shift, if basically shift is pressed, then player speed equals 3. Um, we could have done it in the assignment here. Doesn't matter. Anyways, so then um, here's what you'll see. You'll see that the next thing we do is we assert that our state.x and state.y are of integral types. The reason for that is because we're gonna clamp it, and actually we just want them to be basically like booleans. We don't want any kind of like floating point thing. We could make it so that it would be a floating point, and in that case we could use a controller, and we could actually like, detect input from the controller. But for now, we don't really care about that, so we're gonna omit controller part of it. And then here we can see that we have this state.x, and state.y. We clamp it so that it will be no more than -1 and 1. And then we check if both x and y are 0, then we are going to set the velocity to be 0. It doesn't really matter what the angle is, because if you think about it, our angle exists on a 2D plane like this. So actually I should probably save this file. Where do I save it? Save it pictures, unit circle. So if you look here, basically our angle exists in this two-dimensional plane. So doesn't matter what the value is, it's always going to be on the circle. Like you could set it to 0, it's going to be here. You could set it to the maximum number, and then what's going to end up happening is it's going to go around the circle, and it's just going to keep spinning until it spins into infinity, right? And then at some point it's going to land, randomly somewhere on here. Of course, it's not random because like if you pick like some position here, you know all the numbers that correspond to that position. You just keep adding 2 pi and you'll get all the positions. And also you can keep subtracting 2 pi, so 2 times pi, which is about 6.28. If you do that, you will end up having, your number. Um, so like basically each point here has a number attached to it, and there's an infinite amount of numbers that attach to each point. So it's not like you could set it to, I don't know, 8, and it's not going to be on the circle. It will be because of the way unit circle works and angles in radians work, and even normal degree radians. You know how if you spin 360 degrees plus 80 degrees, you're going to be at 80 degrees. So if you spin infinite amount of degrees, you are still going to spin some amount of 360 degrees plus some remainder, which could be 0. It could be anything else. Infinity is not really a number, But let's imagine that infinity for our case means like a really huge number, but something specific. We could still measure it on the circle. So because of that, setting the velocity, I mean affecting the velocity doesn't really matter. So we can just set the velocity to 0 and that will cancel all the movement. Um, but but here's the thing. Here's the thing. Um, if you look into the other thing here, it may be a little bit confusing here because there are three if statements. Basically, if x is not equal to 0 here, and y is not equal to, so if either of these are not 0, then it's gonna go through these three if statements. Now, the math is, I mean, I have it on paper. I haven't bothered to transfer it to like um, digital format. But the way the math works is you go on your unit circle and you say that this is 2 divided by 4 pi. You see how basically each of these numbers is pi divided by 4 times, and then just 0, 1, 2, 3, 4, 5, 6, 7, and this is 8, but it's also the same as 0, right? So you can say that really, whenever you're calculating what the angle is, all you have to do is you just have to somehow map the 2D position, like with y and x coordinate. You have to map this, xy to some number n that's between 0 and 8, or better say 0 and 7, and you get um, that's how you get the actual radians of an angle, right? So as long as you can map it like this, and the way it's mapped, I'm still working on the more efficient solution, although I don't think I'll actually do that because it's just becoming pointless at this point. But preferably, I would want some formula like, I don't know, 16y minus 4x plus 3, like something like this, something really simple. You just plug in those numbers and it gives you this n. I could not find one just yet. For some, like it's just really hard. But you can, if you work with it, if you just map out, like you make a table where you have all the possible values, all the possible combinations of x and y, and below that you list like numbers 1 through 7, uh, being the multiplier, like like say 7 times pi divided by 4. You're gonna get like this table that, let me just maybe in the comments somewhere here put in this table. Can I please? Like, it would look like this, like x, right? And it will have, I'm just gonna write the first few because the table is like, so it'd be like 1, 1, 0, and it continues onwards. Let me make that a comment, zoom it in, right? Uh, Actually, it's hard to see. Okay, let me do that. So like int x, right? And then you have like your y, and the y would start at like 0 and then like 1 1, right? And then this value of whatever the multiplier of pi, let's say n, that would be starting like 0 1 2 3. This is basically this multiplier that you see right here on the unit circle, and these are x y, these are the coordinates. If you were to basically measure, like if you press the S key, it's going to be here. So the y coordinate is going to be -1. The x coordinate is going to be 0, right? But then if you press both S and D, it's going to be down here and to the right. So the coordinates are going to be 1 on the x and -1 on the y. So these are what, these x and y are. So basically each key up here, where is this thing? So it's what we calculated right here, right? This x and y. And then you basically map values of these to 1 to 3. There should be 3 right here, right? And so on. And if you do the math, then you'll see that basically there are 3 values of y that are possible. So 0, 1, and -1. Because if you look here, the y-axis, it can be +1, -1, or 0. And then the x-axis obviously could be something else, but it's also limited to those 3 values. And in cases where y-axis is a 0, there's only 2 cases where it's 0. It's at position, well, at angle 0 and at angle 4. The other 6, they're grouped together. So let me actually write this aloud for you, right? The other ones, they go like this. So this is -1, -1, -1, 0, and then 1. And then here, it's going to be 1, um, 0, and then -1, -1, and -1. Right. Let me put some extra spaces here, just so it's a little bit more consistent. And then this is like this. All right, so that's the entire table. And you can see here that there is this region where y is equal to 1. And there is another region here where y is -1. And the other 2 values are here, 0 and 0. And what you can say, and again, this is not the most efficient way of doing it because it's a weird way. It might not be faster than just, what is it, 7 if statements, but I'm hoping that it is faster than 7 if statements. Maybe it's not. I mean, it's 3 if this one is 3 if statements, and well, okay, we could actually optimize it to a switch, which we should. But this one, so it's either um, a switch with 8 cases, or it's a switch with 3 cases and 1 addition. Because if you look here, because these are grouped, you could, and you look here, you see how this is this is the y, and this is what the x values are. 1, 0, -1. If you look at this one, it's actually flipped. So it's -1, 0, and 1. So they go in the opposite order because the group of 3 -1s are right here. All right. And so you can kind of see, oh wait, so like if it's equal to 1, then it's going to be 2 minus x. So 2 minus 1 is 3, and 2 minus 1 is 1, right? The same here, except you plus x. So 6, like if y is -1, 6 minus 1 is 5, and then 6 plus 1 is 7, 6 plus 0 is of course 6, the same for 2 here. And then for this 0 that's right here, basically you say, okay, well, there are only 2 cases where y is 0 here and right here, so it's either 0 or 4, so that's basically 2 plus, no, 2 minus 2 times x. So 2 minus 2 times 1 is plus 4, and then 2 minus 2 times 1 is 0, because 2 minus 2 is 0, and then 2 like minus 2 is 4, right? Now, as I said, this is not gonna be it's probably not even faster, because what you can do as well is, because there are only three values here, you could say, well, this is another way of doing it, and I have no idea which one's faster. I mean, we could, we could go on to like, um, there is this website I forgot that tells you how much time it takes for an operation on the CPU. And so, like, theoretically, you could say that, um, you could say that, like, oh, so like a switch is going to be faster than an if statement and an addition. In fact, it probably will. Or you could argue, oh, it's going to be slower or something. We could do that, but here I'm not really sure. I mean, they're kind of almost the same thing. Um, and besides, this function is, even though it runs every frame, unfortunately, we could probably research into how SDL works and make it run not every frame, but I'm not doing that because SDL is just frustrating to work with. Well, point is that, like, theoretically we could optimize this, but it's already optimized enough where it would basically calculate over here with this if statement for 1, -1, and 0. It will calculate what I told you before, like 2 minus stated x, 6 plus stated x, or 2 minus 2 times x. It will calculate these angles. And then, actually, this should be const expr. Can I set it to const expr here? Uh, oh, it needs to be initialized as a constant expression. Okay. Well, we should calculate this stuff here. And so this is where I actually apply it. So I say angle times numbers pi divided by 4. So actually, now that I look at this, um, what I could do, another version of this, which would be the same thing, is to basically say that first of all, we're gonna add 1 to this, to both of x and y, so that they become values from 0 to 2. So basically, -1 becomes 0, 1 becomes 1, sorry, 0 becomes 1, and 1 becomes 2. So we add 1 to it. And the same goes for y. And then we could say that because it takes only, what is it, 2 bits? Yeah, it only takes 2 bits. So we could say that we shift, um, let's say, y coordinate over 2 bits, basically multiplied by what? By 4 or something? I forgot. Anyway, or raise it to the power of, I forgot. Anyway, so like you shift it so that the bit-wise representation would be, so 0 in binary is 0, 0, sorry, 0, 0 like this, right, in bits. No, don't do this. Autocomplete, please. And then 1 is 0, 1. Jesus. Okay. And, okay, it needs a semicolon at the end. And then 2 equals 1, 1, right? So it only occupies 2 bits to represent all of these values. And then we could say, oh, so what we're going to do is we're actually going to say that, like, say a value of x and y, right, a coordinate that is equal to, say, like 0, no, with, okay, yeah, 0 and 2. So in this coordinate system, it would be -1 and 1, because remember we add 1 to this. So we need to subtract it here to, like, so this is basically going to be like the actual coordinate of -1 and 1. And we could say that we arrange it in such a way that we basically look up on this table, 0 is 0, 0, and then we say 2 is 1, 1. All right, and we write this as a hexadecimal number. I forgot which, is it that? I forgot. Anyway, we write this down as a hexadecimal number. So that is just a 2, right? So you can write like, 0x2 for convenience, okay? So it's actually 0x02, just for convenience purposes, okay? It doesn't have any kind of meaning to it. We could just write down 2, but it's going to be make it easier to kind of. Oh wait, that's two. That's a single byte. This is how we would. Mm, yeah, so we write it down like this. Okay, then this is unnecessary, right? So that's equal to 2. And then if it's, say, like a coordinate like 1, 1, that would equal, so this number in binary, that's a, what's that? 15, I think, right? Yeah, it should be 15. And so we basically go through all the coordinates. We say like these are the coordinates, this is what they mean. And then after that, we just say that, well, this maps to, like, I don't know, what is it, a 1 1? Oh, I have the table right here. 1 1 equal to 1. So we would write something like, switch. Don't do this. Oh, the complete, you're so terrible. Like switch on this, like, coordinate, united coordinate, and then you would have, like, say, case 15, um, angle equals 1, like that, right? And then you would also have like case 1, angle equals, let's see, let's do case 2. Case 2 would be, what is it, negative 1, 1? That's like equal to 3, right? And they don't go in order, of course. So like you could do it this way with this switch instead of doing this math. And technically, oh, we're still like doing, we're not really saving anything because we still have to like get to the point of this being, in this case, like in this numeric form. I'm not sure. I'm not sure. I mean, this is not really saving us any kind of like performance or anything. It's just there to like flex that like we are faster or something. I don't know. We have to like actually benchmark it to understand if it's better or worse. So, where's my music? Let me just kind of bump it up a little. So there is no real, like it's gonna be approximately the same speed. And this is not even something that takes like a lot of time. The most amount of time will be spent looking for movement intent components, which there's like a really small amount of them. And it's, if there is a lot of them, it's going to be spent just assigning this velocity here. So, yeah, I don't know. It doesn't seem like it's actually like increasing our performance. I will admit though, that this angle, once we assign it here, like 2 minus theta to x, blah 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 blah, what we should do. Oh, what this happened? Let's get rid of this. Okay, let's put it after this else if. Right. Let me tell you why that is. That is because we're just gonna delete this, so we get all of our angles to that. And you could try to like optimize it in some way of like with addition and so on. I think this is just gonna be faster because you want to basically If this if statement fires, none of this else stuff fires, and we could also make it into a switch. Let's do that as switch. Um, switch case 1. Case -1. I'm not sure if that is something you can do. Case 0. Should be working. What? Can I jump from switch statement to this case label? Is this what you want? Oh, is it because a float angle is not defined up here? It should be. Float angle, I don't know, equals 0. Just the default one. What is your problem? Is it that? Yeah, it was probably this. It should be break here anyway. So this should be a little bit faster. Right. And then that. Yeah, okay, it's fine. So, and then here, instead of calculating it inside of this, you just say like, hey, once you decided what it is, you're gonna set the angle to be, um, well, you could just say it's multiply equal um, pi over 4, right? So that will be a little bit faster. And if we really wanted to, just set it to be angle here, we could like make it like even faster. Um, yeah, like we could theoretically like make it like super just, but I don't even know how to. That's the problem I'm having, because I have drawn on so many pieces of paper so far, like A4 format paper. I've tried like solving equations, all that, and I could not find anything that's like reasonable for me to even invest time into. So this seems to be like one of the fast ways of doing it, and it kind of makes sense because actually, if you look at this, it does look um, it does look pretty good. In fact, we can check if it is good by taking this entire thing. In fact, I want this entire thing. And oh wait, this is not my browser. Let's see. I'm gonna blind you now. Let's go over to Godbolt. I said Godbolt. Godbolt. Is this a thing we can use? No? Okay, let's click this button. Alright. I don't know what this is. I don't actually care. So we are gonna paste this in. And I'm gonna remove. Actually, you know what? It's gonna be just easier for me to just do here. State. Oh wait, it's an int. X. Y. Put semicolon, semicolon, and then here. State. Let's make that uppercase. Site is being updated. Okay, that's fine. Okay, what's it saying? STD numbers has not been declared. Uh, it's not really my problem. Don't need any of this. Okay. Alright, so that should... Hello? What's it saying? So what's this editor? Okay, so compilation failed. See output. There's two of them. Let's close this one. I think that's unnecessary. In function main std numbers has not been declared. I mean, I did add this in. Include numbers. What do you mean? Are you... You're just dumb. Okay. Output. There's the output. STD numbers has not been declared. Jesus. What are you? What is your problem? I do not understand. Has not been declared. Okay, well, screw you. No, let's do this. Const float. Uh, let's just do pi equal 3.14. That'll do. What's that? Oh, it needs to be like this. It's even const expr, I think. There we go. We got output. Yeah, I wish there was a way to disable this highlighting. It is very annoying. What's that? CPP Insight. What? What do you want? I do not understand what it is. Click. Is that what it is doing? Oh, that's what it is doing. Oh. Basically, that's what it's doing. Yo. It's pretty cool. Oh, this is awesome. That's not what I wanted though. Yeah, that's pretty good. What's a quick bench? Let's see. Quick C++ benchmarks. What's that gonna do? Oh, you get benchmarks. Pretty cool. I do not care. Okay, this is not what I wanted actually. Anyway, that's not even gonna run benchmark because it needs to do it a little bit differently. What I am trying to see is, okay, so this is here. This is our, like state and all that. I want to know what the output is. Like, what did it compile to? Before we can actually do that, we need to set the O3 flag. And that just compiled to this. Nothing. Ah, nothing. Terrible. I can't even benchmark it. Okay, let's not use the O3 flag. O3 will not help us. Let's see here. So, what is it gonna do? Oh, so cool. Wow, nice. All right, so let's see what it's doing. First of all, it is going to. I am not very good at understanding the purpose of stuff. I can kind of. No, I actually cannot read what it's doing. But what I can see here is at the end of this entire tirade, it moved into EIX. This, actually not this, just that, whatever this is, which is probably our Y coordinate. All right, it moved it into EIX, and then it checks if EIX is 1, it will jump to this L1, sorry, L2. L2 being some code, otherwise jump to L3 if that's this, which by the way, for some reason, did I really write switch 0, 1, 1? No. Why does it compare it this way though? Hang on. Why is it comparing 1, 1, and -1? That's not what I said. Huh. That's not what I said. I said 0. What? What? Why does it compare it to 1? I do not know. Well, anyway, it does comparison, and then it calls one of these. Then... Oh, wait. Here, it compares it... Let's test. Computes the bitwise logical AND of the first operand, source 1 operand, and the second operand, source 2 operand. Sets the results in the sky, more information available. Okay, so it's just a check. And there's like a different J. Check the state of one or more status flags in the E flags register. Oh, it's like a comparison to 0 or something. Hmm, cool. Cool. And then this. So you can see that this part, is pretty fast. There is something up here, doesn't seem to be that complicated. And then it would just, you know, it would just, keep on going. So let's see what L2 is. L2, L4, L5, 2, L3, L4, L5, and then L3. So I'm not sure exactly what's happening here. I'm not really that good at assembly, but it doesn't seem. Oh wait, that. Mm-hmm. But they all do it. It's like a float cast. Well, anyway, it doesn't seem to be a lot of instructions. Um, I am just thinking like, I don't know. It seems to be kind of okay-ish. This should be pretty fast, okay? I don't know how fast it is, but like it should be, you know, decent speed. Right? Um, and so, um, the thing is that it's gonna be good enough, and it does perform like addition here somewhere or subtraction, depending on what I asked it. Um, but so far shouldn't be that complicated, right? Um, so as a result, let me just see. The one that's here seems to be a bit more complicated because it does multiplication and then, but really it's not like actual multiplication, but I don't know. Well, should be pretty good in terms of like, I don't know, like, this, I honestly do not know if this is even good enough or not, but it, let's see if what I wrote is actually the same thing. Let's build that again. This is what it should be. It should only recompile the stuff that actually matters. Shouldn't recompile other things. Yeah, our diagonals movement still works. All right. And also theoretically our movement on the diagonals should be the same speed. So it should be actually slower to move on the diagonals than it is. Oh, no, no, no. Stop. Stop right there. Why does it go through me? Stop doing that. All right. So I don't know. Seems to be pretty good in terms of like what the what we're trying to achieve. It should be pretty good. So it's still all of it is still functional the way we want it to. The one thing I did not test is if I press all four of the buttons, will it actually move anywhere? It will not. If I press just two, okay. So press WS as well as AD, and then all four of them, it stays in the same spot. So that's pretty good. All right. So our thing works, our addition multiplication, and then looking up it still works. And we can now um, we can now do something a little better. We can actually start writing more code. The thing that I want to do today, I think, is let's see, we have collision, we have movement, we have decent somewhat scaling, which I should fix a little bit. Let's bring it back to about 32. I think the first thing I would like to do is I would like to use a maggot to commit all of that again. Maybe push it to GitHub, but that's not going to be on stream because I don't want to open my GitHub on stream. Not because it's a secret, but because opening your GitHub may or may not weaken the security of it. You never know. So yeah. Um, oh, did it not finish compiling? Yeah, so yeah, I think it did not finish compiling. Um, yeah, it didn't compile last thing. Thought it did. Okay. And now if we run it, yeah, so that's going to be a little bit more towards what we're actually willing to have in terms of like um, our thing, right? So we can move around. We are the cube ourselves. And yeah, we can move around. We can just like move slowly. We can move faster. Kind of like a Gario. But let's probably add, make it so that we're not just moving by ourselves, but we have something like a sprite, maybe. So I did some time ago download some sprites on the web, but what I'm gonna end up doing is um, Google some free 2D art sprites, and I'm actually probably gonna go for just regular art, although it is all pixel art as far as I can tell. Uh, and I am not going to use anything that was made by other people. That looks pretty cool. I am instead just gonna kind of try and make some of my own. And we're gonna try adding sprites basically to our game. But before we can do that, before we can add sprites to our game, we need to, you know what, let's make it a little like a little plan for today. Scratch. I think I had a to-do list in here somewhere. Yeah. All right. So that is biomes. Oh, I didn't have it. Wait, what? Ah, there it is. Okay, physics system. That's done. So we can just do to-do list for today. First one, um, refactor system that's HPP into different files. Second one being that I want um, to add sprite support. I think that's gonna be it. And then maybe if we can do that, all of it, we're gonna add a character sprite. And we will need to draw our own sprites at some point, so might as well do it now. I have heard about people using Blender more and more to make 2D pixel art sprites because it also allows you to do animations in Blender, and it actually is pretty good in terms of like what it can do with animations. It's actually like pretty good from what I've seen. Somebody in Randy's cave showed me this, his like animations and stuff. It's just gonna be better for me to 3D model it. So maybe next one would be 3D modeling time. I don't know. We'll see. Okay, you guys, don't forget to hydrate. Love this thing. All right. So first one that we need to do is refactor system.hpp into different files. In order to do that, what you have to do is you have to save your project, and then I think it compiled, right? We need to run and see that everything works. So now we refactor. After we refactor, we're gonna have to recompile everything again, but only once. So let's start doing that. Okay, so let's see. Um, if we go in here, you can see this is our systems.hpp. I'm gonna create directory under include sand called system and where is it? Um, I am not sure. System. Oh, okay, that's how you do it. And then here, let's see. So the first one is the render. So create file rendera.hpp, and what you'll do is you'll take all of this, you take it out of this, and put it into here. And also, this thing needs SDL types. So just probably take this, add a pragma once, and paste in your SDL. That should be it. It is saying that some stuff is not there, but it actually is. Okay, and so then all of this can just go. And because we have removed a file, sorry, a class from here, we're gonna need to do an include, and we're gonna include sand um, system render. And I could use relative includes, but just to make it more portable, let's do it this way. In my main.cpp, probably will still include this file, the systems.hpp, but other systems will only include their respective file. So then, once we have this, oh, I forgot to commit. Let's commit finished finished controls, and now it's fine that we moved already. It doesn't matter really that much. The next commit will anyway be pretty much this step being complete. I don't think there's any kind of issue with half doing it, half not doing it. Especially since I'm the only one. And like really, Git is there so you can roll back to some change. And I feel like as soon as you are past a certain step, it doesn't really matter what happened to SoundCloud. Okay, just a little hiccup. It doesn't really matter in which order it goes. So, class physics. Let's move that into system, create file, physics.hpp, and some of these, they are, oh wait, physics. Let's see, okay. Yeah, let's take those blocks to D. Let's also do a pragma once, and here we can include sand system physics. Right, see how it sorts them in some way? I don't know how exactly that goes. It's kind of random, is it? I don't really know. Like, I don't really care how it does it. Utility, not sure what this is for. But it's definitely requiring int. And because it's using it here, we can just use a forward declaration. So let's just do include int. Is there like a forward? Yeah, forward.hpp. Actually, let's do this like this, entity forward.hpp. Should work. Alright. And then there are these lonely functions. So let's see, convert physics to render data. Um, this is more to do with rendering. So here's what I'll do. I'll just dd into render and I'll put it down here because it does have quite a bit to do with rendering, and it doesn't really matter if this changes slightly. And also let's include that forward that we had. Entity forward. Um, okay, handle events and handle control events. So create file. Uh, keyboard underscore control dot hpp. I'm calling it this way because it just, I don't know, to me seems like a better way of calling this function. Oh, sorry, this file, because makes a bit more sense. Okay, and of course don't forget to add it in here. Um, so let's just kind of copy this here. Keyboard control, and should be good. Here, of course, do not forget to pragma once, because it's going to say things like redeclaration, redefinition of that. And of course, you need to include int entity forward. I'll just speed it up a little bit in terms of like how fast this thing is. And it seems like the LSP died for a little while. And also, you are gonna include send component player controllable. All right. Seems to be fine. Um, and once we've done that, you can see it's over here. Player controllable. It doesn't really need to be here. In fact, none of this needs to be here anymore. It's going to be just a really small file now. And it might, I don't know, some of those files were not really required as it turns out. Now, in order to prevent stuff from recompiling everything, inside of, say, like handle events, we don't actually need, first of all, we don't need all of this SDL crap. I don't know why it's doing this. And secondly, inside of like, where is it? Inside of this systems, there is already SDL included, right? They're player controllable. Okay, well maybe it's not, but like, point is, SDL.h most of the time will have everything you need. B2 actually, let's kind of keep that. I feel like that might speed it up a little bit. So let's change this systems to system keyboard control. Let's see what could be unnecessary here. Also, it seems like this numbers header doesn't quite exist. Um, which means that I don't know. It is part of. I'm gonna have to see if that's part of the standard. Let's see. CPP reference. No, let's do this. CPP ref numbers. Because this should be part of the standard, I think. Oh, it's not? What? Oh wait, why did I click Google? Also, Google has something weird. Okay, standard library numbers. No. So it is actually mathematical constants by square root of 2. Yeah, pretty cool. So it is actually part of, I mean, at least it's on CPP reference. So if that's here, somebody can just Control C, Control V. Um, that is some cool pixel art right there. I like it. I also realize it's kind of big, kind of high res. I'm not sure if I'm gonna go for that much. And because it's so high res, I want to be able to specify the resolution. Yo, I love this one. This, I love it. I just love this, and this, and this. Some of them are so cool, and this one. Dun, 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 dun. Actually, we might download. Yeah, these are also pretty cool. This one's pretty cool. We need to animate them though. I think there was some kind of. Okay. Anyway, so handle events. I'm not really gonna clean this up. Should be pretty good. Okay, LS language server is kind of trash. Okay, let's see. Handle events. Should now be using this control. Player controllable. Forward. Yeah, should be good. Physics. System. Physics.hpp. Right. Also, this is kind of pointless. I don't know why it keeps including this forward. It's just terrible. Also, like it's got SDL.h and all of this. Let's try removing a few. Component, render data. System, oh yeah, there it is. This is render. Declaration of. Oh, wait. Yeah. And what's your problem? Expect primary expression. Are you dumb? It's not the thing. Sand system renderer. Okay. Oh, are you like complaining that it's not including? Because the header I think has a forward. Let's try that. Renderer has not been declared. Are you kidding? There it is. Yeah, it has a forward. What do you mean? Also here. I don't know, it's just dumb. Renderer camera data has not been declared. What do you want? Oh, is it that like... system? Really? Try compile. Ah, because... invalid use of incomplete type in handle events. And compile. It's just a very boring step. You just do it over and over again. There's nothing special. And it should be done off camera, to be honest, but... what can you do? Okay, it's built. So theoretically now all of them have to, or should at least, not use the same header. So I can still include it in systems, like inside of main.cpp I can still include um, all of my stuff that I want. Like I still can include systems.hpp, it's still gonna work. And let's actually test if it still works properly. Yeah, so we get that, but we get the added benefit that we can actually add or remove stuff without recompiling everything. So let's actually test it. The way I'm gonna test it is I'm just gonna add a new line right here. Actually, let's not add it here. Yeah, this one seems to be fine. Let's maybe remove a new line right here. I don't know. Has nothing to do. Oh, it still puts it there. Anyway, it's modified, and it only modified physics that is CPP. So, and it will rebuild this, and it should also rebuild main.cpp, and then it should link. That should be pretty quick. And if those two files were compiled in parallel, it would have been even faster. So let me quickly Google make multi-threaded compile. Let's see. Dash J4. Okay. So that will be a little faster in terms of compilation. But I need to know make specify where is make file. So if we go back here, let's see if that will actually work. Instead of using cmake, we're gonna write make dash dash file equals build make file dash J4. Okay, one sec, I'll be right back. For now, you guys hydrate, or the opposite of that. Alright, so it does work. Pretty good. Pretty good. Pretty good. So far. Let's just close all these files. Okay. Let's open up this. Okay. Alright. So we have everything. Everything done now. Except that this is not working. No such file or directory. No rule to make target. Make file 2. That's sad. Can I? Can I do? Wait. Can I do it this way? CMake dash dash build dash J4. Well, I mean that doesn't count, of course. Hang on. CMake multi-thread. Oh wait, that's not what I wanted. Or is it? Not sure. CMake dash J4. No. This is what I wanted. So why does it take so much CPU? What's taking so much CPU? Probably loading web pages. Get your builds debuilt. Unix Mac files. So I guess the way to do that would be to do this. Do cd build and make dash J4. Let's see. I should really ask this in Doom Emacs. How do I run? No, how do I specify a custom. Because the reason why I'm not Googling it is because I Googled similar questions and it's hard to find an answer. It takes a lot of time. It's just easier to ask. Like just and people are gonna load you with like extra info. So how do you specify custom build and run commands in Doom Emacs? Actually, they already know it's Doom. For project, so that would be commands spc p pc and also space pr. Hang on. Okay, that's gonna be good enough. They are um, they are saying that like I could theoretically just make a script and put it under um, yeah, like this is not really gonna work. Can I use CMake to like pass additional? Hmm. Oh, look what I found. It's this. Also, somebody's already typing out the answer, I hope. I hope they are. Okay. Let's see. Proj. I think it's a projectile feature, right? So projectile Oh, wait, you can run a named command. I did not see. Oh, wait. Projectile, please. Mhm. I really want this to not be a thing. When I open the project, I just want it to open like, um, I don't know. I actually don't want it to open anything. SPF, find file, SPZ. Switching projects. Ah, they were just asking another answer. No, I'm not gonna get my answer to my CMake stuff. Because it would be really nice if it would just automatically be set to some default. This affects all commands built on top project run projects command line. Like. Okay, so it seems that if I do projectile, configure project, uh, hang on. Mm, compile. Oh, invalidate cache. That would be pretty cool. Let's see again. Okay, here's what we're gonna do. We're gonna do space H key space B C. Compilation read command. You can force the prompt with the prefix argument. How do you set it up? Then compile an interactive and compile function defined in this. Hmm. Mm-hmm. One sec. Mm-hmm. Okay, that's not really what I'm looking for. Okay. Doesn't seem like we can actually set it properly. Um, so let's just keep it to that for now. Oh my god, there's too many includes. There really shouldn't be so many in here. But, you know, it works, so it works. We are gonna need to do something. For example, once we have all of the, I mean, we already have it in here. Like if I go here, we can move around. We even have this like boost. Alright. Um, so we want to add what? What was our goal originally? Our goal was to refactor it into different files. That's done. Add sprite support. That was what I planned. Um, so in that case, we are simply going to make um, oh, this configuration really like just completely made me just forget what I was doing. Add sprite support. So we want to add sprite support. The way we're gonna do that is gonna be the real use of um, we need to go into a renderer. Not here though. Although here as well, but like oh wait, the first one we need to do is we need to reflect our sprites inside of render data. So render data component will contain information about animations a little bit later. But for now, let's just keep inside of here a sprite, and we could keep a pointer to it. Instead, let's not keep a pointer to it. Let's instead do it this way. We're gonna keep a um, bool sprite equal false. All right, and we're gonna do this. We're gonna say that if the sprite equals false, if the sprite equals, where do we even render? I forgot. This is where render. So here we're gonna ask ourselves if render data dot sprite. So if not sprite, then you're gonna do this. Oh, and it should be in brackets because after you create this thing, you then do this. Else, you are going to have to load a sprite. Now the sprite itself will be probably something constexpr. So let's see here. SDL render sprite. Actually, we don't even need. Okay, well, I mean it's clip rendering and sprite sheets. You almost cannot see that yellow. Actually, you can if you have a good monitor. Sometimes you only want to render part of the texture. A lot of times games like to keep multiple images the same sprite sheet as opposed to having a bunch of textures. Oh, multiple images on the same sprite sheet as opposed to having a bunch of textures. Using clip rendering, we can define a portion of texture to render opposed to rendering the entire thing. So we need texture wrapper class, L texture, load from file. I think we're gonna load from a char array. Well, actually, no, but we're not gonna do that. We could theoretically put like the assets into the executable. It's not hard, and it shouldn't really increase the size of it. But what's really cool is that we can actually do all sorts of weird like compression and stuff with it if we really wanted to. But we're not gonna do it, as I said. So deallocates texture, random. Mm-hmm. Get width and get height. Oh, this is such a weird way of doing it. You put this at the bottom. I don't know, it's just everybody does it, but it does not make sense for me. Okay. Here, making a small tweak with rendering function, we create a texture class. The render functions accepts. Mm-hmm. Okay. I mean, we could actually implement this if we wanted. Um, do we want? Do we want that? I think we should close this, by the way. Actually, kinda, yeah. So, we're gonna use bitmaps because bitmaps are easy. I don't know, there's just no real reason not to use bitmaps in my opinion. Like, there's just no, like, well, what's terrible about bitmaps? I don't see a problem with them. Like, why not use bitmaps? Are bitmaps I think are just storing like raw data, which is, and it's not a lot of it, so using it seems to be okay. So in that case, we should Google SDL load bitmap, and GIMP can create bitmaps, by the way. Oh wait, it's Pascal SDL. We actually want just lazy foo or this. Yes, Control C. Oh wait, why am I doing this? So let's think of it. When we load up our renderer, we actually, the renderer, yeah, it should know about the bitmaps and all the sprite sheets and everything. Um, it should manage them. So let's see. What do we need to store? Our bitmap. Bitmap should be global though. Like in terms of, like it should be a separate object in my opinion that would pass in. Oh my goodness, this is getting complicated. I'm not sure how to go about it, so let's just, you know what? Let's just do this. We're gonna have a SDL surface. Um, I don't know, here. I think it's a pointer that they said. Yeah, it takes a pointer. Um, tile map, and we're just gonna initialize it as a null pointer, and then, by the way, let's see just how much is it recompiling. Well, physics recompiled, but that's fine. Uh, I'm not sure if that took more or less time. But with all of this, we are going to say that in the constructor right here, we need to load our bitmap. Do we need to free it afterwards? Load BMP, we just need to free surface. And that is not this, it is a tile map. And inside of Renderer, after we load in the renderer, we can actually start loading the bitmap. So we're gonna do this. Except that entirety of this is tile map. And then here we need the image path. So let's make it as a dun, 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 dun. Oh, you can also save BMP. Pretty cool. So load BMP, and let's load. Um, Actually, load BMP. What it should do is it should call the asset manager and ask it, hey, asset manager, where is this thing located? But the thing is that asset manager is not going to exist just yet because the only thing we're going to have is the player. The asset manager probably would know a little bit better, and we should have some kind of asset management system where it like knows what the tile map is. I don't know if you can insert like metadata inside of BMP. That'd be pretty cool actually. Anyway, load from file. Well, let's load it from assets slash tilemap dot bmp. And for this, under sand here, create file assets tilemap dot bmp. And this is going to, this can't fail, so we are going to do SDL. Oh, sorry. How do we? SDL assert tilemap. All right. And once we load it, we can actually use it now inside of the renderer. So if we are using the bitmap, then we're gonna need to say that for now, the entirety of the bitmap will be um, the character image. So we don't have to worry about that being an issue just yet. And let's see. So they said that you can. I mean, you could, maybe. What's it saying? SDL rect, render quad. Okay. Mhm. Render screen, render copy, gRenderer, mTexture, clip, and render quad. Interesting. Um, what is mTexture? It's a texture. Oh, we don't use a texture, we use a surface. Okay. Um, in that case, we can just use, so surface will load us a BMP, and then we can just probably click this SDL surface, and it will give us like something like render surface or something, please. SDL render surface. Okay, it says the render copy, so it takes a renderer. So let's just do that. SDL um, render copy. Okay, and it tells you here. So first of all, you need a renderer. Then you need a texture. I do not have a texture, so I'm just gonna write texture. I know I don't have it, but who cares? SDL rect is gonna come from up there, so we'll just call it rect for now. I know I don't have it, but that's fine. And then const SD. Wait, what is? What's that? Source destination. Render at rendering context. Oh, this is how it works. Right? You take a surface, take a background. That's weird. Hang on. Anything. Okay, so the source one, that's the first one. That one defines the size. So basically it's the size of the surface, right? The destination uh is this SDL rect. So actually this if statement will work this way. If it's not a sprite, you draw a rectangle, else you do a copy. Now here, instead of copying it like this is going to be a little bit different here because this rect here is going to be SDL. Why is it like this? Hello? I don't know why it's like that. SDL what? What SDL rect? Um, surface, or better say sprite size, And Emacs is just completely going wild for some reason. Probably because I did something weird. Not sure what. It's not happy. Oh, it's not happy. Maybe there's an extra bracket somewhere. There is. Okay, now it seems to be fine. Now the texture itself is something we don't have. So let's in here change this. Do we actually need to keep the surface? Or can we just copy it to the texture? You load surface, create texture from surface, and then you free surface. So surface is not actually required to be kept. So we can just do this real quick. What we can do is we can say this is a texture tile map, and that is what actually goes in here. Tile map, and it's gonna tell me no such function to call. Um, let's see. Text texture and the renderer. Okay, I think I mistyped texture. And now that should work. Hello? What kind of parameter does it take? Render SDI texture pointer. Well, that's kind of what we did. What do you... I don't know what's happening. Let's try to compile this real quick. Oh, I wish it would highlight the part that is incorrect. Because that should be fine now. No? Tile map equals, okay, you cannot assign it to a surface. However, what you can do is you can take your, down here, instead of assigning it directly to a tile map, you can say here you have SDL surface, temporary surface equals SDL I should be a pointer, and then after it asserts the temporary surface, it will then use this function called as the create texture from surface. You pass in first operand renderer and the surface, which is temporary surface, and you say your tile map is equal to the result of that. Once you've done that, you call you call that, and one last thing, and it should work. Dun, 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 dun. So we should be able to load surfaces now and render things. Okay, so everything still works. Let's make sure we can push them. Yeah, pretty fun. Okay, so with that, we can start making something a little bit better. Also, I can see that there's clutter. Should be this way. This is so much cleaner. I wish the console was like over here, and I would like put stuff here instead of down below. Maybe there's a way of configuring it this way. I mean, I could open the vterm and just open it on the side, but I'm not really gonna to. Okay, so now we need to determine the size of this sprite. And this is the thing that I love about this, is that you can just do dot x equals 0, dot y equals 0, width equals 16. I mean, it doesn't have to be this. Dot h equals 16. So that will be the size of it. And should still compile. You see, it's a little bit faster now in terms of compiling, I think. Maybe it's not, I'm not sure. So, as a result, we should be able to load our surface and mark our player as this thing with the surface. So where we create our player, when we movement, set as box, be the body. Oh, wait a second. We have no way of telling if the player, because see, here in the while loop, convert physics to render data. That one will in place or replace that. So it's not actually preserving the information about the the thing. So putting in this info, basically putting a boolean inside of the um, inside of the render data kind of removes the whole point. Um, which means that either we need to set the boolean on that render data all the time, or we can just add a component and the so let's see here, render data. It it's always like I mean this thing is running every frame nonetheless, and get position. What does it return? It returns inline const b2 vec2 reference. Can I go to definition, please? Yeah, it returns by reference. So we can cache this as a position, and oh, this is genius. This is what we can do. Because it returns it by reference, we actually can get the references and store them in our data structure, and then basically whenever we pull out X and Y, we just pull out references to them. So the way we're gonna do it this time is we're gonna say that this system requires a render enable component, and if so, look, this system requires a body and render enable. Render enable does not exist. That's fine because we're gonna add it now. So here, after this, struct render enable. And render enable, what it will do is here should propagate down. What's it say? Okay, yeah, render enable. So now that this is here, we can say whatever has this render enable component, we're going to in place or replace the render data. Now, render data is going to change because this float x and y are going to be float references. All right, these are references now, and okay, that's fine. And what we're gonna say is on initialization, we need to set them to specific things. And you can see here, we're gonna create our bivec2 position, and we get position, but wait a second. Oh, okay. We are not going to reset their position inside of this struct. We are going to say, I mean, we could just set it to like render data and just keep, yeah, let's just thinking about it. So let's do this as a reference, and it's gonna say, hey, you're casting away const. So let's do const ref. And then here, you're gonna say that when you in place your render data, you'll pass position.x, position.y, but they are going to be passed, or at least they should be passed by reference. So ultimately, that should do something interesting. I just want to see that happen. Okay? Let's see that happen. Because something interesting is going to happen. Oh, shoot. The matching function for call. Swap render data, render data. um, let's do it this way. Let's create render data. Um, yeah, renderer data. We're gonna say that x equals position that x dot y equals position dot y. Uh-oh. Not like we're modifying them or anything. Um, and that will be it for most of them. And then here, um, we're just gonna specify render data. Let's see if that compiles. It should. Oh my goodness. Use of deleted function. Render data operator equals. Oh my god. Struct render data. Is implicitly deleted because default definition would be ill-formed. Okay. Non-static. Cannot use default assignment operator. Let's see. The matching function for call to swap. Candidate. I guess we could then place a const render data on it. I mean, yeah. That fix it? No. Sheesh. Render data is not derived from std bear. Oh my goodness me. Um, operator equals. Can we define it? Mm, let's try this. Let's try position.x and position.y. Mm. Use of delete function equals is implicitly deleted because the default. Okay. How can I somehow obtain a copy of this? What I could do is I could, instead of float x and y, I could say I have a const b2 vec2 position as a reference. And obviously it's not going to compile because we need to pass in our position into here. Let's build that again. Render data has no. Wait, did it build this file? Oh, I think it did. Oh, wait, okay, I'm not sure how it did though. Let's try that again. Dot what? In fact, we don't even need this reference. Why is it not? Okay, so that seems to be working. Let's just confirm that it can build that one. It seems like it can't actually. But it's complaining inside of render and it's saying that an instantiation of render operator mhm, required from here. Construct render data has no member named X. So if we go here, you can see that it is indeed not having no member called X, but it does have a position. And camera data also has a position, but it doesn't have to know about it. Hoping those were the only ones. What are you saying? Use of deleted function operator equals. You gotta be kidding me. No. What are you saying? What are you saying? Oh, render data reference operator equal render data reference data. You are saying that you cannot return data. Can you not? I'm gonna end you. What are you doing? The matching function for call swap. An instantiation of a void. I don't think that this will work, to be honest, because I feel like it wouldn't. Template argument deduction substitution failed. Oh, what are you doing? Oh, wait. What kind of template deduction? Enable if is swappable? Okay. Uh, Shoosh. Jeez. Can I not store a const reference inside of a... Oh. 1 second. I need to visit a ent the ent Discord and ask for help. It's always a good question to ask. Sorry, it's always a good idea to ask questions because not like it's not like you're gonna actually like um yeah, you know what? Let's just get rid of all this trash as well because we don't need any of this. Uh, okay, let's see. Bounty compiler complains that I can't swap it and I can't equal it. Assign. Also, reason. And now we wait. Now we wait. Hmm. You know, it's been 3 hours. I think I'm gonna go. I'll resolve this off stream. I don't know why this is complaining. Uh, just because I saw somebody in the VC and I'm like, I want to be in the VC with them. Not really. Um, but I cannot stream that, so I think I'll go. Maybe I'll stream a little later. Also, it's nice not to stream in the evening, so I have a little bit more time to actually prepare for sleep and not go to bed at like 1 a.m. Yeah, a little abrupt, but who cares? And not that anybody's watching. I mean, some people may be watching back the VODs, but not like they're actually doing this. I have not seen a single person watch back the VOD yet. Maybe that person who's in the VC will help me. But as I said, I don't stream Discord on stream. Okay, just keep that in mind. That's part of the reason why I'm leaving, because I want to be on Discord with somebody, but I can't on stream because that's my policy. So, bye.